It is commonly accepted theory in neuroscience that our senses not only work together to create a view of the world, but also inhibit and compete with each other. When processing any scene in front of us, the brain will decide on the most relevant senses and deactivate all others. What we find is that when we stimulate the visual cortex, there is a significant and replicable deactivation of the auditory cortex each time. Essentially, we're hearing less as our brain gives more resources to the visual elements in front of us. This is most apparent in the blind, who do not actually hear better, but hear as well as any of us if we closed our eyes and just focused on our hearing. However, these studies have a problem. We don't only focus on one sense at a time. We actually process dozens of different sensory signals each second. My research looks to correct this. We used functional imaging and some very simple stimuli. We wanted to look at a visual flashing checkerboard, some auditory beeps, and also some artificially generated muscle twitches to stimulate the senses. Our hypothesis was this: if we stimulate each of the senses, we will again see a deactivation in the other senses, as can be seen on the top left of my slide. However, if we were to stimulate two senses at once, the one that's left over would show an even greater deactivation than before, and that can be seen on the bottom left. The actual findings were this: we replicated previous findings. As we stimulated any one sense, we showed a deactivation in the other senses. However, during dual stimulation, each of the senses organised itself differently with different neural setups. The auditory system had the same level of deactivation during a single or a dual trial. It had one level of off and did not change throughout the experiment. The somatosensory cortex did show a greater effect from dual stimulation. It would actually inhibit the other side of its own cortex, particularly during trials where we stimulated the somatosensory cortex and another region. It was more interested in controlling itself than worrying about the other senses. Finally, the visual system did follow our hypothesis. When it was completely non-task relevant, it actually showed a greater level of deactivation, but in previously stimulated locations only. What this shows is, our original hypothesis was far too simple. Each of the senses actually works in unique ways with different neural architecture leading this effect. I thank you for your time, for your visual and auditory attention, and for your somatosensory inhibition.